Welcome back, guys, to Lane's ED Enhancement. Now, today is a very special day. We give God thanks once again. And today I've been asked to do a special request. What I've been asked to do is to break down the vessel operations and productivity calculation in this course, Marine Terminal Operations. So we're looking at some marine terminals, container, liquid, dry bulk. Now, in the example that we intend to use, there are a couple of terms we need to be familiar with. So let us look at those terminologies. First, let us look at productivity. Now, the measure of productivity often expressed as a ratio of an output to a single input. In other words, output per unit of the input over a specific period of time. 2. TEUs and moves. We are going to use them interchangeable in this exercise, but for now, TEUs are 20-foot equivalent units and is a measure of the volume in unit of 20-foot long containers. The moves mean any containers that are loaded and unloaded. As I said, we are going to be using them interchangeably in this particular exercise. So don't be mixed up with what we are going to be doing. All right. Now, let us look at number 3. Number 3, ETA, ETC, ETD/ETS. ETA, estimated time of arrival. ETC, estimated time of completion. And ETD and ETS, estimated time of departure and sailing. Now let us look at 4. In this exercise, we are going to be looking at some special containers. These containers have been classified as DC, which is damaged container, as you see in the lower left. The dimensions of the containers is affected by dents, so wires will have to be used to unload. 5. Overwide containers, lower right. We see where the cargo is extending over the width of the flat rack. So it is also going to need specialized lifting gear to unload. 6. Over high containers. Cargo extend above the height of the open top container and will also need specialized lifting gear. 7. Hatch cover. Now these must be removed to unload containers which are below deck, and all of these takes time to load and unload. They cannot be done the traditional way. They take time to handle each and every one of these. Now, I can't overemphasize that I would love you to subscribe, like, and to share. Once you're enjoying these videos, once you're gaining from these videos, please do so. Now let us review the information in the vessel operation. Here we have a vessel with 6 bays. It will be worked by 3 key cranes, A, B, and C, each working 2 bays as indicated here. Each working 2 bays. Crane A will be working bays 2 and bay 6. Crane B will be working bay 10 and 14. C will be working bays 18 and 22. Good. Now, what we have seen on this vessel is that there are a number of damaged containers, overhide containers, overwide containers. All of these will have to be used with specialized equipment to unload. We see that also each bay has one hatch cover each. Very good. Now let us review the question that is given. The question reads, the MV Logistics sailed from New Orleans on December 12th, 2022 at 03:29 hours at 25 knots for the port of discharge Kingston, which is 3,735 nautical miles away. It continues that free pratique was granted 25 minutes after docking. Total TEUs/moves to be discharged 1,500 and total loading set at 152 20-foot containers, 62 40-foot dry van containers, and 75 40-foot reefer containers. It continues. The moves/TEUs are evenly distributed over the 6 bays to be worked by the 3 gantry cranes, as indicated on the diagram that we looked at earlier. Now the productivity of each crane, A, 25 moves per hour, B, 28 moves per hour, and C, 30 moves per hour. Now we're going to look at the table that shows all the special containers that are at the different bays and how we are going to handle them. The time it takes to handle each and every one of them. So let us look first and foremost at the key. The key states that the one damaged container will take 14 minutes to be handled. A over wide would take 5 minutes. A over high would take 7 minutes. And it is going to take us 18 minutes to unload and load back the hatch covers. 18 minutes to load and unload each hatch cover. As you can see in the bays, what's indicated there, bay 2, the number of damaged overhide and overwide containers. There's no overwide in bay 2, but in bay 6, there are overwide, overhigh, and overwide damaged containers. Similarly, bays 14, bays 10, 18, and 22 all indicate the number of damaged or special containers that will be handled. Now, the question asks, A, calculate the estimated time of arrival in Kingston, the ETA to Kingston. In B, it asks us to find the estimated time of completion of cargo operations. In C, it asks us If the pilot arrives 23 minutes late, we are to calculate the estimated time of sailing. Finally, in D, if the next port is San Juan, which is 1,784 nautical miles away, we are to calculate the estimated time of arrival in San Juan at a speed of 20 knots. So now let us look at calculating the estimated time of arrival. In doing so, we know that speed is equal to distance over time. Therefore, time is equal to distance divided by speed. In essence, we are calculating the transit time between both ports. Now let us look at this transit time solution. The vessel is traveling at 25 knots over a distance of 3,735 nautical miles. So therefore we divide 3,735 by 25 and we get 149.4 hours. And since we want to know how many days that will be, we are going to divide by 24. We are going to divide by 24 to determine the number of days, and that gives us 6.225 days. Now, using two decimal places and we'll be only going to minutes. However, some lecturers might require that you go to seconds. If so, you know you will have to continue multiplying by another 60 to determine the seconds. But in all intents and purposes, we're just using up to the minute, day, hours, and minutes. That's where we're going to stop. So the 6.225 will give us 6.23 days. Good. Now, we take the 6 days, and now we want to know what 0.23 of a day is in terms of hours. In doing so, we will multiply 0.23 by 24, and we get 5.52 hours. Again, we remove the 5 hours, and we are left with 0.52 of an hour. We need to know how many minutes is 0.52 of an hour. And so we have 0.52 times 60, which gives us 31.2 minutes. As I said, we are stopping at minutes. If we were continuing to seconds, we would continue by multiplying 0.2 times 60 to see what that is in seconds. So the transit time between the two ports is 6 days, 5 hours, and 31 minutes. Now, for us to solve, since the vessel would have sailed as indicated in the question on December the 12th at 0329, we now need to add the transit time to the sailing time to give us the ETA that it will reach Kingston. And so we will add 12 in terms of days, 03 in hours, 29 in minutes. We are going to add 6 days to that, 5 hours and 31 minutes, which was the transit time that we got. That gives us 18 days, 9 hours. Therefore, A is answered by December the 18th at 0900. The vessel would reach Kingston. That is the answer for A. Now let us continue. But before we do so, as I said before, if you are liking it so far, remember to subscribe, like, and share. Now let us look at the start of the cargo operation. But first, we were told that free pratique was granted 25 minutes after arrival. We have the arrival time, and so we now want to know what free pratique is. Now, this is granted after a vessel docks in a port and the quarantine officer visits and advises everyone that there are no communicable diseases aboard the vessel. So the workers can now begin the operation. So the arrival time, as we said, was December 18 at 0900 hours. Free pratique granted 25 minutes after, and so the operation will start on December 18 at 0925. Good. Now, solving for the number of containers on the vessel. That's our operation. Now, the total we were told to discharge was 1,500 TEUs. Total to be loaded was 152 20-foot containers, 62 40-foot containers, and 75 40-foot reefer containers. Now let us work that out, the TEUs. We have 152 times 1, since it's 20-foot equivalent unit, so times 1, plus 62 times 2, since that's a 40-foot, which is 2 20-foot, and plus 75 times 2. That gives us 152 plus 124 plus 150, which is a total of 426 TEUs to be loaded. We will now add the overall moves on the vessel, which is 150 discharge plus 426 loading. That gives us 1,926 to be loaded. Now, since special containers are involved, we need to make a particular move. Now, all the moves were distributed evenly over the 6 bays. Therefore, each bay would have 1,926 divided by 6, which gives us 321 TEUs. Now, since each crane, because we're talking about crane A, B, and C, since each crane is going to work 2 bays, then they would have 321 times 2, 642 moves or TEUs each. Now, since the special containers are going to take some time to handle, and they cannot be handled by the actual crane in terms of the productivity, we cannot work the productivity, it's going to take a longer time. We must first subtract them from the total move of each crane. And then the remaining containers now can be discharged using the crane. And so with crane A having 6 special container to handle, it would be 642 minus 6, which leaves 636, with the productivity of 25 moves per hour. That would give us 25.44 hours. When we break that out, we will get 1 day, 24 hours, 1 hour, make 25 hours, and the 0.44 of an hour we multiply by 60 to tell us exactly how much minutes we are working with. So we have 1 day, 1 hour, and 26 minutes for crane A. Now, continuing, we have the special containers on the hatch cover to look at. We have the damaged containers, 3, and it said 14 minutes to handle each, so that will give us 42 minutes. We have the over eye, 2 of them, and it takes 7 minutes to handle each. that's 14 minutes. We have the over wide, we have 1, and it takes 5 minutes to handle that one. We also have hatch covers to handle. Remember, it takes 18 minutes to handle the hatch cover for each bay. Take it off and put it on, and each crane will be working 2 bays. So it's 2 times 18, which is 36. That gives us a total of 97 minutes, which is 1 hour and 37 minutes. So the special containers at crane A will take 1 hour and 37 minutes. Now, after we have calculated those, we are going to now add it to the crane productivity to give us the overall result. The crane productivity we got was 1 day, 1 hour and 26 minutes. So now we are now going to add the special container and hatch cover time, which is 1 hour and 37 minutes, giving us grand total of 1 day, 3 hours and 3 minutes, which will be the completion time for crane A. Now let us look at crane B. Crane B has 9 special containers to handle, plus the hatch covers. Now let us look at this now. 642 minus 9 leave 633. With a productivity of 28 moves per hour, we are going to divide 633 by 28, which gives us 22.61 hours. That is 22 hours, and 0.61 times 60 gives us 37 minutes. With the damaged containers, there are 4 damaged containers and it takes 14 minutes each, so that gives us 56 minutes. The over height, we have 2, 7 minutes each, 14 minutes. The over wide, 3, 5 minutes each, 15 minutes. And the hatch cover, again, 36 minutes. This gives us a total of 121 minutes, which is 2 hours and 1 minute. Now we are going to add those to the crane productivity. The crane productivity result was 22 hours and 37 minutes. And now we are adding the special container time, handling of the special container time, which is 2 hours and 1 minute. And we end up with 1 day and 38 minutes for the completion time of crane B. Now we go to crane C. We are going to calculate the number of containers because crane C has 10 special containers and also the hatch covers to handle. So 642 minus 10 gives us 632 with a productivity of crane C of 30 moves per hour. We divide 632 by 30 and we get 21.07 hours, which is 21 hours and 0.07 times 60 gives us 4 minutes. So it's 21 hours and 4 minutes. For damaged containers, there are 3 and it takes 14 minutes each. That's 42 minutes. For over height, it's 4 and it takes 7 minutes. That's 28 minutes. For over wide, it's 3 and it takes 15 minutes. It takes 5 minutes each for a total of 15 minutes. And the hatch covers, again, 36 minutes. This gives us a total of 121 minutes, which is 2 hours and 1 minute. Now, the crane productivity that we got was 21 hours and 4 minutes, and we are going to add now the special container handling time, which is 2 hours and 1 minute. That gives us a total of 23 hours and 5 minutes for the completion time for crane C. So now we have the time it takes for crane A to work, time for crane B, and time for crane C. So the result, as we say, is A, 1 day, 3 hours, 3 minutes. B, 1 day and 38 minutes. C, 23 hours, 5 minutes. So the longest gang is crane A, and the longest time to complete is the one that determines when the operation will end, when the operation will complete, when the vessel will be complete in its cargo operation. And since crane A now is the longest, then we know that on December 18th, which we started at 09:25, we are going to add, right, the estimated time of cargo completion. We are going to add 18, December 18, 09:25. We are going to add the longest time to it, which was crane A. Here we see where it's 1 day, 3 hours, and 3 minutes. That gives us December 19th, 12:28 hours. That would be the completion time for the vessel, which is B, the answer for B. Pilot arrives 23 minutes late. Therefore, the estimated time of sailing would be the completion time of the operation, which is December 19, 12:28, plus 23 minutes for the waiting time on the pilot, which gives us 19, 12 hours and 51 minutes. Therefore, the estimated time of sailing is December 19th, 12:51. And that's the answer for C. Again, using 2 decimal places and only going to minutes, we are going to work the transit time to the next port. Now the next port, which is San Juan, is 1,784 nautical miles away. And the vessel is going to be steaming at 20 knots. Therefore, time, as we said, is equal to distance, 1,784 nautical miles, divided by a speed of 20 knots. That gives us 89.2 hours. And we want it in days, hours, and minutes, as we said earlier. So we are going to divide 89.2 by 24, and we get 3 days and 0.7 of a day. Again, we use the 0.7 of a day times 24 to determine how many hours, and we got 17.28 hours. The 0.28 hours we multiply by 60 and we get 16.8, which, since we're not going to seconds, is 17. We would round it up to 17 minutes. Therefore, transit time would take 3 days, 17 hours, and 17 minutes. Now, the vessel sailed on December 19th at 12:51. Therefore, the ETA to San Juan would be December 19, 12:51, plus the transit time of 3 days, 17 hours, and 17 minutes. That gives us 23 days, 0608. Therefore, the answer to D would be December 23rd at 06 hours, 08 minutes. Now, people, let us do what's important to me and to this channel by subscribing, liking, and sharing. Now, I hope that this would have assisted you. And so, remember, always feel free, visit the channel, visit the other videos, and have yourself a blessed day. Ciao.